Hello and welcome back, and if you're new here, welcome to Absolutely Math. Make yourself comfortable, relax, and prepare yourself to learn. Alright, so if you watched the previous video, or even if you're new here or you already know what we discussed in the previous video, we basically discussed the difference between a function and a relation. That relations and functions, basically the same thing in that they map inputs and outputs, relate two things together, but there's a difference between the two, which we went over. In this video, I am going to quickly reveal one of the main reasons we study functions, one of the core parts, graphing, something you should be familiar with from recent math classes as an IB student right now, but we won't be going into the types of functions that we graph. Rather, we will be looking graphically at what makes the difference between a function and a relation and how we could tell that difference quite easily. If you want to get straight to that part, then just skip through to the minute up here. Now, just to recall, we graph a function by plotting the inputs and the corresponding outputs given by that function on a Cartesian or XY plane. The inputs would go on the x-axis while the outputs would go on the y-axis. For example, let's take an arbitrary function. Let's say the input is 2 and the output is 2 as well. That would form a point. And we could also represent these points by writing them as ordered pairs, as we've learned. Input-output pairs. 2 is the input, 2 is also the output. XY pairs. And if we would continue to plot points given by some random function on this plane, we could possibly form a curve or a line, depending on how the function is defined, or what the function is. But that's not the focus of this video. Types of functions and stuff like that are for other videos. Those are also things you should be familiar with, but we'll cover types of functions. This was just to recall. And now let's move on to the main point of this video. Alright, so in the last video we said that there is a difference between a function and relation, and we looked at that conceptually. We looked at that through ordered pairs and function mappings, mapping diagrams. But how about if we're given a function? How about if we're given a function's graph? A function's graph. How could I tell, or how could you tell that a function is a function, not just a relation, graphically through its graph? And we also looked at a type of function in the last video, the one-to-one function. How can I tell a function is one-to-one graphically? Well, alright. I'm going to outline that very briefly here. Alright, and there are two tests we're considering here. So we're going to apply tests to graphs to tell whether they're functions or if they're even one-to-one functions, just as the title says. All we have to do is test. Now there are two tests that we're going to be considering. One is for functions. For functions, we do what we call the vertical line test. So we just take a vertical line and use that on our graph. More on that. But the second test is to see whether or not a function is one-to-one. For that, we use the horizontal line test. Same thing as we did the vertical line. Just consider a vertical line and apply that to our graph or curve. How? Now, how do we do so, like specifically? Well, for that, let's consider an example, alright? So let's keep these in mind, okay? Now, a good example would be a simple function. Let's say we have this function on the xy or Cartesian plane, so y-axis, x-axis. Say we have this line, a linear function, something you should be familiar with. This linear function. Is it a function? Are we calling it the right name? Is it a function? Well, let's use the vertical line. Let's apply that to our curve. Oh, it is a function. Well, How do I know? Because this vertical line intersects the function itself just once. Now there's the key. When the vertical line is applied to a curve or a line or a linear function, just like here, as long as it intersects that curve or function just once, it's a function, indeed. So here, vertical line test again, intersects just once, and again, just once. One more time, once. How about another? Once. See, this vertical line test, or the line itself, is just intersecting our function over here once. So it passes the test. It is a function. Let's take another example where it would turn out to be just a relation and not a function. Okay, let's say we have this over here. Something odd looking, but it's the only example that comes to mind, is this over here. It looks like a flipped parabola, flipped quadratic function. Let's do the vertical line test. Okay. Now you tell me, what was the condition? Well, intersection at just one point, while here, the vertical line test, or the vertical line, intersects our curve twice. So it's not a function. So goodbye, curve. You're not a function. Now, how about the horizontal line test? All right, let's take a look at the horizontal line test. Horizontal line test tells us whether or not a function is 1 to 1. So a function is already a function, but the horizontal line test is applied to see whether or not that function is 1 to 1, which is a type of function. Let's just take this random function again, linear function, on the xy plane. All right, so here it is. What do we do instead? Horizontal line. We apply a horizontal line. Okay, there's one horizontal line. Is it a 1-to-1 function? Yes. Again, the same condition. It has to intersect our function just once. Let's check here, just once. Here, just once. Here, just once. All right, nice. Linear function is 1-to-1. All right, now, how about, let's see. How about another example? Okay, let's do another example where the function is not 1-to-1. All right. Well, here we have our x and y. Let's take our quadratic function, this parabola looking curve. Okay. Apply the horizontal line test. Is this 1-to-1? No. Why? Well, that's because there are 2 points of intersection, and for it to be 1-to-1, there has to be just 1 point of intersection. All right, now, why does all this work? Why do we choose to use a vertical line and apply it to our function to test whether or not it really is a function? Why do we use a horizontal line to see if that function is 1-to-1 or not? Well, here's why. First thing I'm going to say is that these lines guide us. That's basically it. They guide us. Now, how? We have to return to the definition of a function, or what makes the difference between a function and a relation. So what makes the difference? Well, if you've seen the previous video, or if you're new here, or even if you know it, I'm just going to state what makes the difference. For a function to be a function, every input has a unique, or actually has one output. One single input can't be mapped to more than one output. For example, let's just use a mapping diagram here really quick. Let's say I have 1, 2, 3, 4, 5, 6. Neglect this 6 here. Let's say we have 3 to 5 and 2 to 4. This is not a function, because see, this input is repeated twice for 2 outputs. What would be a function is if every input, or if this 3 had one input here, had one output there. This 2 has its output here, that's fine, as long as each input has just one output. All right, we get the point. And so if we test this on a function, let's see. Let's say we have some curve here, okay? Here, okay? Now, if we put our vertical line, we can put even many. We see that this input here has one output. Input, one output. Input, one output. So these vertical lines tell us that, because there's one intersection point. Now, you might see this even better or more clearly if I give an example of a function or of a graph that's not a function. Let's see. Let's try this upside down or flip parabola. If I put the vertical line, two intersection points. It's against the rules. Why? Because we see this input, this single input, let's say it's 3, is mapped to or related to 2 outputs, which is not part of the definition, or it's against the definition of a function. All right, that's that. Same thing goes for the one-to-one function. We just have to return to the definition. The key word is at most. Every output has to be related to at most one input. That's the key phrase. So let's use the mapping diagram again, or the map here. X, Y, okay. 1, 2, 3, 4, 5, 6. At most, one input for every output. That's the relation that should occur. 1 to 4, 1 to 4, 2 to 5, 3 to 6. Is this 1 to 1? Yes. Very quickly, yes. Why? Because every output is related to at most one input. No more than one input is related to an output. Now let's see a quick example again here. 1, 2, 3, 4, 5. Let's say we have 3 to this, 2 to this, 1 to 4. Is this 1 to 1? Nope. Why? Because this output over here is related to 2 inputs. Not at most 1. It's more than 1. 2. So it's not 1 to 1. Using this definition, or returning to this definition of one-to-one functions, we use the horizontal line test. All right, let's say we have a function like here. Again, let's use a linear function. Is this function one-to-one? Apply the horizontal line. Yes, by looking at the intersection points, there's just this horizontal line intersects the linear function just once everywhere. So it is one-to-one, but returning to the definition, we could see it's for sure one-to-one because let's say we have this input here, 3, and let's say this is 6 over here. 3 is related to 6, no more than that. 4, negative 4, let's say, is related to here, whatever this is here, 2.5. See, every input has one output. It's a function and indeed one-to-one. See, this output has just one input, no more than that. Let's now see an example of a function or a curve that is not one-to-one. Here, actually, here, apply the horizontal line. 2 intersection points. Straight away we could say it's not one-to-one by the horizontal line test. But why exactly? Well, because if we take, for example, this output here, okay, let's say this output is a 7. Okay, I'm just choosing arbitrary numbers. We see that this output is related to 2 inputs. And for a function to be one-to-one, an output has to have at most, or should be related to at most 1, and this is more than 1 input. See, 7 is an output, it has 2 inputs, here and here. So yeah, that's that. Alright, so I hope you've learned about the vertical and horizontal line tests and where they apply, how they work, why they work, and I'll see you in the next one, and I wish you the best of luck. Please consider subscribing. Find my email in the description box below. Send me an email if you have any questions, suggestions, anything of that sort. Alright, I'll see you in the next one. Goodbye.